that's where CAD is very important. We're able to map out the size, all of the location of the holes. If you look at the braking assembly on the left, you can see that all of the holes, all of the screws, the distance between the plates, everything is in the correct location so that when this is manufactured and it goes into the chassis, it's in the exact position that it's supposed to be. And, that's very important. So yeah, it's really cool because now we can bring these two assemblies together and see how they're going to interface in real life. And this is really important for the planning stage and stuff. So now I'm going to talk about how you actually CAD, right? So there's a lot of CAD programs out there. SolidWorks is probably the most, popular. Dassault Systems makes SolidWorks and CATIA, which are considered the two industry standard programs. But once you know one of them, you basically know all of them. SolidWorks, Autodesk, Inventor, Fusion, CATIA, Creo, Rhino, Siemens, they all basically do the same thing. But SolidWorks has a wide user community. There are many tutorials out there. And generally for the ease of use, it's very powerful. So if you're looking to get into 3D modeling, SolidWorks is probably where you should start. So now that we have a rough introduction, I'm actually going to do a tutorial. So, I mean, a lot of you might already know how to use SolidWorks, but I'm just going to go into how to make this basic part. So the first thing to notice is, this part is symmetric on both sides, right? There's this plane here and it's a mirror image on both sides. I'm going to go into SolidWorks and show you guys some stuff. Okay, so here's SolidWorks. Kind of very, a lot of stuff to look at, right? There's all these ribbons here. There's whatever, what is this, right? Okay, so here you have your feature design tree. And the feature design tree basically tells you how do I put my SolidWorks in dark mode? I will let you know. It's but basically the feature design tree over here will have all of the sketches and the features that you make to design your part. So you can go in and interact with them. And then there's evaluate, where you can go in here and you can measure things. You can check out the mass properties. Sketch is where you actually sketch your things. And then features is where you make them into 3D. So those are pretty much the three most important things that an engineer will work with. So getting started with this part, when you're doing 3D modeling, it's very important to keep in mind how something is going to be made. And so if I were to be making this thing, which is like some small thing that might sit on my desk, it's probably going to be made out of a block of wood, and somebody's going to go in with some tools and cut it so that it looks like this. Something else I forgot to mention is you can change your units really conveniently down here. Right now I have IPS, which is inch, pound, and second. For this purpose, I'm going to work with millimeters. So let's get started. So what I'm going to do is I'm going to take this part and model it from the top down, and I'm going to model half of it and then show you how to mirror it. So I'm going to choose my top plane, which is just like the top, and then I'm going to right click, and I'm going to choose this symbol here, which is sketch. So now you see that SolidWorks takes you exactly orthogonal to the view, and you can begin sketching. So here you have a variety of tools. You have the line tool, center line, midpoint. You have different circles, you have different spline lines, different rectangles. So I'll leave you to play around with that. But I'm just going to get started with a basic corner rectangle. So the first thing you have to do is you just have to draw a random rectangle. And as you can see, everything right now is blue, right? So what that means is that things can be dragged around and there's no dimensions given to this part. Obviously, that's very important, right? We need to give our box some dimensions. So I'm going to make this, let's say 40 millimeters wide and 50 millimeters tall. So what I just did was I selected the Smart Dimension tool, and then I just clicked on the lines, and it gave it a width, height, and a width and height. Yes. So why is it still blue, right? I've added dimensions. Okay, well, now you need to give this box a location within space, right? You need to give it some reference to the coordinate axis. So here's your little representation for a coordinate axis. And when you see I hover over this, I get this like orange little dot. So I can click on that. I can press Control and I can click on this top line. And you can see that I get this menu. And I can set the relationship between the coordinate and the line. So I'm just going to say midpoint, which what that did was that it made the origin the midpoint of this line. So now you can see everything is black. If I try to drag something, nothing gets dragged. So I'm just going to press Exit Sketch. Now I have a sketch, but it's not in 3D, right? That's what I want. So I'm going to go to the Features tab, and I'm going to press Extruded Boss Base. So as the animation shows, it's going to extrude the item up. So if I press Extruded Boss Base, you can see that now I'm in an isometric view, and I can set how tall I want it to be. So let's extrude this to 32 millimeters. And I'm just going to press check. And now you can see I have this box. One thing to mention is that if you click down on the scroll wheel, you can pan around in 3D. If you press Control and then use the scroll wheel, you can move the object around. And if you press spacebar, you can get this view cube and you can choose the kind of view you want. So this is front face. I usually like isometric, which is just this nice 3D perspective. Okay, this doesn't look anything like this. It's a lot of work, right? Okay, so now the next part, as you can see, is there's like this cutout here, right? So I'm gonna make that cutout. So what I can do is I can click on this top face and I can sketch on this top face and then I can cut it out. So I'm gonna right click, I'm gonna press sketch, and then I'm gonna use my view cube to go orthogonal to it. And I want it in the same orientation as before, so I'm just gonna rotate it to be like this. Okay. Now I'm going to choose the rectangle. I know that the cut is along the edges, so it's open. So what I'm going to do is, since I have a corner rectangle, I'm just going to choose the corner here, and then I'm going to choose another corner here. And as you can see, oops, I'm just going to Control Z. As you can see, what ends up happening is that I have now a rectangle that's constrained on 3 sides because it's using the dimensions of this box and saying that these coordinates are they're fixed to the edges, right? So the only thing left to do is to fix the z-axis. So I'm just going to choose Smart Dimension, and I'm going to say that I want this cut to be 41 millimeters, right? So what it's going to do is it's going to cut out all of this area. Exit, so check, exit sketch. And now if you look at it in, oh God, if I look at it in 3D, now I got to make the cut, right? So it doesn't cut all the way, right? So we got to leave it some gap. So if I go into my features, I can choose extruded cut. And now this is going to allow me to choose how far I want to cut this. So let's cut it 22 centimeters or 22 millimeters. So as you can see, it's now been cut, right? So not quite what it's supposed to look like. Let's make this middle cut here, right? So it cuts all the way through the ground. So what I'm going to do is I'm going to do the same thing I did before. I'm going to right click on this face. I'm going to press sketch, and I'm going to go orthogonal to the view. Again, going to rotate to make it in the view I want it to be. Okay, now something that you noticed is this cut does not go all the way over here, like you can see that view over here, but it goes all the way up to this wall, right? So what I want to do is I want to choose corner rectangle again, and I'm going to just click anywhere on this line. And when I do that, it's going to make the top of the rectangle coincident with this line. So I'm just going to, drop it anywhere. And as you can see now, I can change the dimensions of the box, but I can't change the location of this top line of the box. And that's because it's constrained. I want it to be. Now I'm going to smart dimension meters, 22 millimeters wide. I want to give it, also, I apologize, my internet's kind of bad, so I might cut out. But let's say I want 9 millimeters in between. And as you can see, 9 plus 22 is 31, plus another 9 is going to be 40. So if you remember, this length is 40. And now I want it even on all sides. So I'm just going to say I want the distance from the bottom to be 9. Okay, simple. Now I'm going to exit the sketch. And as you can see, I have this. Now I'm just going to cut it, right? So extrude cut. And now I can choose how much I want to cut it. So I want it to cut all the way through. So instead of specifying a value, another thing I can do is I can go here and select the end condition. And I can say I want it to go through everything. I want to go up to the next surface, or, I have all these myriad of options. This is important because if you're going to model something later, SolidWorks might give you a hole where you don't want it to give you a hole. So, you want to specify the end conditions correctly. So I'm just going to select up to next. Now, if I pan around, I have a nice hole in the middle of this. So, if we reference back to this, we're getting there, but not quite, right? So the next thing that you notice is that there's this, V shape here. So I'm going to use my view cube and I'm going to press on the front view. So now I'm looking at the front view, right? And I want to cut out of this. So I'm going to right click on it. I'm going to press sketch, and now I can sketch on it. So again, I want the V to cut out of the top. So I'm just going to click on the line. And then I'm just going to click on the line again. Now I'm going to constrain this. So let's give it 10 millimeters from both sides. So I'm just going to click the edge, and then I'm going to click the point. And I'm going to say I want this to be 10 millimeters away. And I want it symmetric on both sides. So I'm just going to do the same thing on this side. And then I have to constrain the center, right? So I'm just going to click the edge again, and I'm going to click on this vertex. I'm going to say 20. Okay, it's still not constrained. Why? Because I can move it up and down, right? So smart dimension, and I'm going to say I want it 10 millimeters from the top. Okay, everything's black. And so now I'm going to check, and I'm going to exit sketch. Now, if I go to try and cut this, it's not going to cut, right? I have nothing I can select here. So why is that? So if I go back, if I right click here and I press edit sketch again, I don't have a closed region, right? I have to specify a closed region to tell SolidWorks that I need to cut, only this part. Otherwise, SolidWorks is going to cut, an infinite region, and it cannot do that. So I'm going to go back to my front view, and I'm going to create a closed region. So I'm just going to click this vertex. I'm going to click this vertex, and I'm just going to press escape. And now you can see this line is already black because these vertices have already been constrained. So the line in between them obviously is also going to be constrained. Now I'm going to exit the sketch. I'm going to click on it, and then I'm going to press extrude cut. Now I can cut it, right? Same thing that I told you before. You don't want to just cut into infinite space. You want to specify your boundary conditions. So I'm just going to say up to next. All right, looking pretty good, right? All right, so now I just have to make these holes here, or these cuts, and then we're almost done. So I'm going to start here. I'm going to go orthogonal to that view. I'm going to sketch on it. And as you can see, like, this gets pretty repetitive. I have different tools I can experiment with. I can make a hole here instead. But those are some things you can play around with. So again, I want the cut to be coincident with the top line, right? So I'm just going to make a square there, and then I'm going to dimension it. So let's say from the top of the face to this line, I want that to be 4 millimeters. Let's say that from each of the edges, I want it to be 16. And let's say I just want the width of this thing to be 8. So now, as you can see, 16 plus 8 plus another 16 is going to get you 40. So now that this is fully dimensioned, I'm going to go ahead and I'm going to make that cut. So I'm going to exit the sketch. I'm going to press extrude cut. And now, as you can see, I can cut it. Again, boundary conditions are important because if I did this, it would cut through this wall too, and I don't want that, right? So I'm just going to click here and I'm going to say up to next. So there we go. Now we have this. So now we just have the cut that's on this face, and then we're almost done. So again, I'm going to use my view cube. I'm going to click on the right view, and now I'm orthogonal to this. So I'm going to right click on this face. I'm going to press sketch. And same thing, I want it coincident with this line, so I'm just going to do that again. I'm going to smart dimension it. So let's say for the sake of consistency, I want this to be 4 millimeters. Let's say I want the width to be 12. And let's go 20 millimeters from here. How about that? All right. You know, once you start to do it enough times, it becomes quick and intuitive, right? So if I exit the sketch, I have to cut it now, right? So something you notice is that this cut here and this cut here are the same. So I could make a cut on this face, or I could make a cut on this face, and you know, it would be the same thing. So what I can do is I can choose extrude cut, and I can change my boundary condition to be through all. So now it's going to go through all of the faces. All right, so now I made this part, and as I mentioned, it's only half, right? So I'm going to make the other half. So what I can do is I can go to in features, I can go to mirror, and the first thing you have to do is you have to choose which face you want to mirror this about. So or face or plane, sorry. So I can mirror it about this face, or if I drop down from here, I can choose. You can see that it's highlighted, right? The front plane. So I'm just going to click on that, and then features to mirror. So what features that I made here do I want to mirror? So if I just press boss extrude 1, boss extrude 1 was the box we made, and then all of the subsequent cuts, right? So I'm just going to press shift, and I'm going to select all of them. And now you can see that everything is selected, and it's going to mirror it. I'm just going to press check, and now we have our part. So a couple of other things to look at is SolidWorks allows you to apply material properties to your parts. So if I go here on materials and I right click and I press edit material, there are a lot of, you know, given SolidWorks materials. If you have your custom one, like you can add a custom one, but let's say I was going to make this out of balsa wood. So I'd select wood, I'd select balsa wood, I'd press apply and then close. And you can see SolidWorks gives it this, SolidWorks gives it this nice texture. If you zoom in, you can see the grains of wood. And the cool thing now is that if I were to go to evaluate and click on mass properties, I can actually see that my part weighs 6.02 grams. So SolidWorks is going to take the dimensions of my part. It's going to take the material density, all of the properties, and give it a mass. This isn't going to always be accurate. So, you know, take it with a grain of salt, but, you know, it's pretty cool. You can look at the center of mass. So about X and Z, right? I made it about the center. So it's 0 there. Y, because we extruded up, so it's a positive value. And then the other thing is that when you're modeling, sometimes you can forget the dimensions of things. Or if you're looking at somebody else's work, like you might want to see how big something is, right? So here's the measure tool. And all you have to do is click on two faces. Let's say I wanted the width. And you can see that SolidWorks gives you the normal distance. It gives you the distance between the 2 points that you clicked on. It gives you the delta X, the delta Y, the delta Z. It even gives you the total area of the 2 faces that you click. So yeah, SolidWorks is really powerful. You know, there's even a simulation tab. I could run a new study on this and, you know, do some force analysis on this. Like if I were to put a force here, like how this thing would break, et cetera, et cetera. So I think SolidWorks is really cool. For dark mode, I don't remember how I did it. I think somewhere in the settings here, you can go in and something with the appearance or color. Oh, colors right here. So colors, background, and then I just chose dark. So I hope that was helpful. I hope that was informative. If anyone has any questions, I think questions will be after. But I'm going to stop sharing now so Bobby can share.
All right, so I'm going to share my screen.
In this section of the workshop, we'll be introducing what 3D printing is and how to design for it. And my name is Christopher Wu.
And I'm Bobby Laviguer, and we are part of the HyperXite dynamic subsystem.
So first of all, what exactly is 3D printing? Nowadays, 3D printing has become a very widely accessible piece of technology, but 3D printing is just a type of additive manufacturing, which focuses on adding material rather than traditional manufacturing methods, which typically remove material. Um, Today, we'll just mainly be discussing material extrusion / fused deposition modeling, which is what consumer 3D printers do when they printing stuff. And essentially the way it works is that heated material, which is typically a thermoplastic, is extruded through a nozzle and deposited onto a platform layer by layer. And this extruder is controlled by 3 motors to have full range of motion within the X, Y, and Z axes. You can kind of think of it as like a automated hot glue gun. So what are the steps of going from a design to a print? For designs that you create yourself, you might start out with a CAD design in maybe SolidWorks. You can save this CAD file as an STL file, and the next step, which is STL repair, is kind of optional. This is for more complicated designs that use surfacing, in which there might be a lot of holes and gaps in your design. And so STL file or STL repair is kind of there to prevent your final print from having those holes and gaps. However, it's pretty unnecessary if you're just using extrusions and whatnot to make your model. And finally, within a slicer software, this STL file is converted to G code, which we'll discuss more about later. So if you're using SolidWorks, you can go to the file option and then click Save As and specify it to save it as an STL file. What STL file stands for is Standard Tessellation Language. And essentially, they use triangles to approximate your 3D model. You can see in the left figure, it's a very triangular shape, and so it doesn't use as many triangles to approximate it. Whereas the figure on the right is very circular, and so it needs more triangles to be able to closely approximate the geometry of your design. Here you can see an STL file, which is loaded within a slicer software. One that's typically used is Ultimaker Kira. Next. So really quickly, some terminology is these are the settings. A lot of these terms are settings you'll see in a slicer software when you're about to go from that to a print. So there's layer height, which is the thickness of each layer. Typically, a thinner layer height will give you a more high quality print, but it'll take more time. Now, next is shells, which is the number of passes around the surface of each layer. Infill is just the amount of material you're going to be using. Support material, we'll discuss later, and brim / raft is material extruded at the base of your print to create a larger surface area, which allows for greater adhesion to the print bed. So some useful knowledge is knowing what settings to use based off what you're printing. In the case for printing for strength, there are about 3 to 4 things you might want to consider. So obviously, if you use more material, your part is going to be stronger. So how can you use more material? There's 2 settings you can specify within the software is the number of shells. Typically 2 is normally used, but you can use 3 to 4. And infill percentage, and typically you use about 10 to 15%, but maybe for parts you want to be more stronger, you can use 30 to 40%. The other 2 factors are orientation, and you can run a static structural simulation before you print it to also see where there might be failure points. So orientation, this is actually pretty important for 3D printing. And when you're determining orientation, you might ask yourself 2 questions. What's the best orientation to print for strength? But also, what's the best orientation to use the least amount of material? Because some orientations, you might need to use more support material to get your print. So in these 2 figures, you can see this kind of, this random model, it might be better to print it as you see on the left rather than on the right. The one on the right has, I think, like 3 problems with it, which is that, first of all, the surface area between each layer along the vertical axis is really small. And so if you were to apply stress to this design, it'll break pretty easily, but more so than the design on the left. or the orientation on the left. The second problem is that there's very little surface area between this and the print bed. And so it might have trouble adhering to the print bed as you're printing it. And the third is as you're printing higher and higher along the vertical axis, there's a lot of instabilities that grow. And so it's usually just not a good idea to print something that's kind of shaped like this, that's oriented like this. Yeah. Finally, is you might want to consider running a structural simulation. So this kind of goes hand in hand with 3D printing. 3D printing, you can print really intricate and complex designs. And so you don't have to print all of the material, just you can remove material to allow for more optimized design. And one way you can do this is in SOLIDWORKS, there's a topology, you can run a topology study after you've designed a component, and that'll run a structural simulation on your component and tell you exactly where you can add and remove material based off what external forces you're applying. And yeah, I'll hand it off to Bobby from here.
All right, thank you, Chris. And so we're just going to talk about more tips for 3D printing. And some of these are going to include tolerances, inverted angles, holes and arches, and then, of course, whether your print bed is level. We'll just touch upon leveling your print bed real quick. One of the easiest things you can do, some 3D printers will come automatically level. Otherwise, it will require you to level it yourself. And the easiest thing you can do is with a piece of paper and just make sure it's flat and make sure it's at a good height by moving down your nozzle and seeing if you can move your piece of paper underneath the nozzle. But to begin with tolerance, the most important thing to keep in mind when you're 3D printing, I couldn't tell you how many times that I have had a failed print just because I screwed up with the tolerances or I didn't consider tolerances. And so one of the rules of thumb, it varies from machine to machine, but you can go with increasing your tolerances by 0.04 inches to have a tight fit for your part. But like I said, that does vary by machine. And so I would recommend once you get a 3D printer or begin working with a 3D printer, to get some sample prints, determine whether the 3D printed completely cooled model and how much bigger it is compared to your SolidWorks model or whatever CAD software you're using. And so another consideration are inverted angles. And so essentially you want to have the smaller the slope corresponds to a greater amount of stepping, and you want to have the least amount of stepping possible. And so what that means is, as you can see the picture on the right, the slope is less. And so that corresponds to a greater amount of stepping, which means it just means that there's more material hanging off the part. And so it doesn't cool properly, etc. And so having a steeper slope just means there's less material to hang over, and then it eliminates problems like that. Another consideration are holes and arches. And so with holes and arches, you want to actually print them so that they're parallel to your print bed, which corresponds to the XY plane. And so that goes hand in hand with the slide before, in that you don't want the material to overhang, just because for cooling purposes, it might deform, or you might get anything you'll see in these two left pictures. The far right picture is how you want to do it, parallel to the bed. And then another important consideration are the materials and properties. And so there's lots of 3D printing filaments out there. It is plastic, and so there's lots of plastics out there. PLA is going to be the most common. It's the cheapest, and you can usually get away with a majority of structural builds by just having a high infill density with PLA. And then next is ABS. It's stronger than PLA for sure, but if you're using your 3D printer at home, it does emit fumes, and so it's just kind of a trade-off you have. It's good for workshop ones. And then there's also PETG, which has great mechanical properties, but it may string while printing. And so, like I said, there's lots of various various filaments that you can use for 3D printing, but it all depends on what kind of 3D printer you have and what you're limited to. And so overall, 3D printers definitely have pros, but they also have cons. And so overall, 3D printers are relatively precise, as long as you consider the tolerances that I talked about. They're consumer friendly, they're super easy to use. You just got to get through learning CAD software, and then using a slicer software is pretty self-explanatory, but the CAD part is definitely the hardest part. You can make intricate designs. The material's low cost. You can get a whole roll of PLA for 20 bucks. It's great for prototyping, and then it's fast post processing. Some of the cons, though, it does take a while to print a part, especially if it has a high infill density, because that just means it's got a lot of layers it has to go through. And so that's a trade-off for printing a part you want to be strong. It would be strong, but it's going to take a while to get there. And then additionally, you may try to print a strong part, but it might not be stronger than a traditional manufacturing method. And then it's also temperature intolerant. And some of the resources that are commonly used, especially for grabbing like nuts and bolts and common CAD files, you can use GrabCAD. GrabCAD's home to so many users who just make CAD files. And so you can go ahead and go on there. This is just a sample of like what their website looks like. But you can literally find so many things on there. I found a PS5 controller on there that I printed out, so that was pretty fun. Thingiverse is another website similar to GrabCAD. And then Reddit definitely has a lot of open source tutorials and like users to help you. And then there's also a lot of on-campus resources. I know we are not on campus, and so some of you might not have been exposed to those. But some of the on-campus resources include FabWorks, which is for engineering students. In FabWorks, there's numerous 3D printers, and that's just one of the areas or one of the locations that has them on campus. But we actually also have 3D printers in our science library. And so you can go ahead and go in there and 3D print. I think the FabWorks ones are a bit better, but that's just a personal opinion. But that concludes the 3D printing workshop. And now I throw it back to Mahek.
Awesome. So we have an upcoming workshop. It's actually next quarter, week 2. We'll be sending out more details through email, Instagram, Discord servers. It's going to be about printed circuit board design. It'll be using Altium. Our electronics team will be running that workshop. And basically, we'll go over how to design your own circuit board using Altium and kind of learning the basic structures of PCB and the basic components used for designing a circuit. And if you have any sustainability projects or any kind of other projects in which you want to design a PCB, this would be a great workshop to attend. And that's basically it. Does anyone have any questions or discussion about anything that we went over?
I had a question just in general about senior design projects.
Yeah, of course.
I've heard that like senior design projects can recruit people who aren't in their 4th year. When does that typically happen?
Right. Okay. So it really depends on the project. For us, we take 3rd and 4th years mostly, but we actually have a freshman right now on the team, Adrian. But it really depends on kind of the openings that year and the skill set. We usually recruit in the fall, but starting last year, we started at the end of spring / like into the summer. And I think we'll be doing that as well this coming spring. So we'll be sending out the recruitment emails probably closer to the end of spring quarter, early summer. So you can expect it to come out then.
Okay, thank you.
Yeah, of course. Does anyone have any other questions? Yeah, go ahead.
I was gonna say, I got a quick question on bed adhesion. If you guys have any go-tos besides like a glue stick, if you tried any of the other like tips, tricks?
I would definitely recommend using a braft or a rim, like what Chris was saying. some slicer softwares, they allow you, like that's a setting you can use. When you're printing, you can select, I want a brim. And I haven't had too many failed prints once I selected that, because a glue stick will definitely, it'll help you initially, but the more surface area you have on the print bed, the more it's going to be secure. And so having a brim definitely helps with that. And so
keeping using PETG, because I've had issues with PETG because that just loves to either warp or stick to the nozzle.
I haven't worked with PETG before. I don't know if Chris has. No, yeah, I only work with PLA, and so typically
make sure to keep your bed clean, and like if you touch the print bed with your fingers, the oil from your fingers will get on it, and that can affect print quality a lot.
Thank you.
Yeah, that was pretty much.
Does anyone have any other questions or anything they'd like to discuss? Okay. Someone asked me if they want to apply for the team, how much skills they would need to have in SolidWorks, and if anyone else is interested in applying in the future. Essentially, it varies on the role that you apply for. Some roles don't really require it. Some of the mechanical subsystems is kind of a requirement. So when we send out the application, we'll usually write, or we will have a list of all the software that you should be familiar with for the roles that you're applying for. And it also depends on your other skills, previous experiences, and interview as well. But yeah, so you should, if you're trying to apply for any of the mechanical subsystems, then you should be pretty proficient with SolidWorks.
I have a question.
Yeah, of course.
Which software stand out to you and to the crew the most?
It depends on which subsystem. Is there a particular subsystem that you're interested in applying for?
No, just mechanical systems in general.
Okay, yeah. Well, it depends even in the mechanical systems. If the leads want to talk about that for braking, dynamics, piping, and cooling.
Sure. So for dynamics, SolidWorks is a major part of what we use for our workflow. We're designing things on paper, doing some analysis, but when we actually get into it, we model everything in SolidWorks, run simulations with SolidWorks or ANSYS, depending on what we need, and do our drawings in SolidWorks for manufacturing. So it's a critical part of our workflow.
Cool. Thanks.
I had a quick question real quick.
Yeah, of course.
When what is it called, like the print labs or something, when they were open, how do you like do you bring like a USB drive with your files on it, or how does that work? Like, how do you use the lab?
Bobby, Chris, do you guys have experience using 3D printing labs?
On campus?
Yeah.
Sorry, I didn't hear
Yeah,
the
on
question.
campus.
I know Rapidtech has 3D printers, and a lot of clubs have started buying their own 3D printers as well. If you want to 3D print something, you can contact Ben Dole, and he runs Rapidtech. And I believe it's like $4 to $5 an hour to print something. I would honestly, instead of using on-campus printers, you can also print at a library as well, but it's all pretty expensive. $4 to $5 an hour is not too worth it. If I were you, I would just buy a 3D printer because they're pretty cheap. A lot of the entry ones are pretty cheap now, going for like maybe $180 to $200. And so if you consider just a lot of the cost up front, it would last you better than using on-campus resources, in my opinion.
To answer your question though, FabWorks on campus, you can schedule an appointment with them, and then you go in and you just take your design on a USB drive, and then the attendant there will like help you get started. They'll show you how to use the machine if you haven't. It's pretty cool.
Side note, does anyone know if the 3D printing club at UCI is still going? Because I remember I was a part of that for a quarter, and it was like $25 for a quarter, and then the price per hour dropped to like $2, which is easier than $4.
I don't have any contacts of them, but I don't think they're going this year. Last time, because I remember I was talking to them last quarter or last year as well. I'm not too sure what happened to them. Sorry about that.
All good.
I had another question. What type of 3D printer would you guys suggest getting if, like, I would want to get a 3D printer?
What's your budget?
Cheap. Broke college student cheap.
Ender 3 is gonna be your best bet, but it's gonna take some effort.
What's it called?
I dropped it in the chat. The one that me and Chris use, and the one that's pretty budget friendly for us college students, it's the Ender 3 Pro. And yeah, as a majority of people that I know that 3D print at home, this is what they have.
Okay, thank you.
Any other questions? Okay. Yeah, then that's it. Thanks for coming, everyone. Yeah, if you have any questions, email us or message us on Instagram. If you need contact information, let us know. But yeah, that's basically it. Thank you for coming.